Finding missing angles using basic trigonometry with Tutor. Here are the beginner questions, some of the easier questions that you're likely to find on this topic. When two sides of a right angle triangle are known, we can use the inverse trigonometric functions to find the angle. In this case, we'll be using them to find the unknown angle marked as D, correct to 1 decimal place. We can use the mnemonic for remembering the trigonometric ratios in right angle triangles. SOHCAHTOA, spell SOHCAHTOA, and these triangles can be used in the same way as we would with questions such as speed, distance, time, density, mass and volume. Firstly, we need to identify which triangle and therefore which ratio or identity we'll need to use for each of these questions. We can do this by labelling the lengths of the triangle in relation to the angle that we're trying to find. So the length opposite the angle we are trying to find will be labelled as O to represent the opposite. The length opposite the right angle is always the longest length labelled as the hypotenuse, meaning the length next to the unknown angle is labelled as the adjacent. Next, we circle the two lengths which are known. The hypotenuse is 12 centimeters and the adjacent is 2 centimeters. And the triangle, along with the identity that involves the adjacent and the hypotenuse, is cosine. So using the triangle CAH, when finding an unknown angle, it will always be the bottom left, the trigonometric ratio that we'll need to cover up. And that's because the angle is always attached to the trigonometric function. So if you want to work out the angle, you'll have to do the inverse function. So on your calculator, shift cosine will bring up the inverse function of cos, represented as cos to the -1. And inside the bracket, we need to do the adjacent side divided by the hypotenuse. In the same way that a fraction works, if you have a at the top of the fraction, you'll be doing a divided by h. So inverse cos of the adjacent is 2 divided by the hypotenuse, which is 12, meaning D is 80.4059, which will round to 80.4 degrees to 1 decimal place. For the next question, I'm finding the unknown angle marked as F. The length of 13 is opposite the angle, and the one opposite the right angle is also known, which is the hypotenuse, meaning the one next to it is the adjacent. Using the two lengths that are known, opposite and hypotenuse, the triangle and ratio involving opposite and hypotenuse is sine, so the triangle SOH. Again, working out the angle will mean covering up the function of sine, and to find the angle I can do inverse sine of the opposite divided by the hypotenuse. 13 divided by 15, that gives me F, which is 60.0735 and rounds to 60.1 degrees. Lastly, I'm finding the size of the angle marked as E. 5 would be the opposite length. Opposite the right angle is the hypotenuse, meaning this one must be the adjacent, and the two known lengths are the opposite and adjacent. The triangle involving those two lengths is the one involving tan, TOA. Finding the angle will mean covering up the function of tan, and on my calculator, shift tan will give me the inverse tan of the opposite divided by the adjacent, 5 divided by 7.5, giving me angle E of 33.690, which rounds to 33.7 degrees. On to the intermediate question, with a slight increase in difficulty. Find the missing angle X. Give your answer to 3 significant figures. Whenever you have these types of questions, where you have one shape connected to another, it's unlikely you're going to be able to use the triangle highlighted green to find X straight away. There'll be an additional step using the other shape attached to it, which we'll need to do first to help us find X. And that first step normally involves finding the shared length between the two shapes. So to find this length, I can label it as the opposite to the angle provided. 9 is opposite the right angle, so will be the hypotenuse, meaning this length is the adjacent. This question involves the opposite and the hypotenuse. That will be the sine ratio and the triangle SOH. I'm finding the opposite length, so cover this up, and this tells me that I need to do sine and attach the angle of 30 degrees. Close the bracket, and because it's next to, that means I need to multiply it by the hypotenuse, which is 9. That gives me an opposite length of 4.5 centimeters. Now I know the shared length, That usually provides me with the information that I need to go on and answer the question. To find x, I can label 4.5 as the opposite. 10 would be labelled as the hypotenuse, meaning this length is the adjacent. In this case, I'm finding an angle, so I need to circle the two lengths that are known, and that would be the opposite and the hypotenuse. We're using the opposite and the hypotenuse again, which would be the sine, relationship and triangle, but this time I'm using it to find the angle, so I need to cover up the function in the left corner. And to find this angle, I'll need to do the inverse sine of the opposite, which we've just worked out to be 4.5 centimeters, divided by the hypotenuse, which is 10. This gives me an angle of 26.7436. Placing my rounding line after the third significant figure would give me a final answer of 26.7 to three significant figures. On to the advanced question, one of the trickier questions that you're likely to find on this topic. The points P and R have coordinates -3, 3 and 3, 8. Find the bearing of P from R. The use of a diagram will help us to understand the question. Starting off with point P, which has a coordinate of -3, 3. R has a coordinate of 3, 8. When you compare the x coordinate of R to the x coordinate of P, R would be further to the right hand side, given that it's going from -3 along to 3. Then when we compare the y coordinate of R to the y coordinate of P, we can see that it's larger, meaning it would be going in a positive y direction like this. So R would be somewhere here. Finding the bearing of P from R will require some angle formed between the 2 points. So connect them together, and this forms a right angle triangle. I can use the coordinates to find the lengths of the horizontal and vertical lines in the right angle triangle. In the x direction, it's gone from -3 to 3. That would be a difference of 6. And in the y direction, it's gone from a coordinate of 3 up to 8, meaning the length or the difference would be 5. To find the bearing of P from R, we're going from R, which will be from this point. Bearings require you to measure from north, so extend a line with an arrow and label this as N for north. Next, a bearing requires you to measure the angle going clockwise from the northern direction, and you continue until you reach the direction that you're heading towards. And since we're going towards P from R, we'll need to find this angle highlighted green. We know that this angle highlighted going from north to south will be 180 degrees, representing a half turn. So we can use the right angle triangle formed to help us find this angle highlighted blue so that we can add it on to the 180 degrees. Labeling my right angle triangle, 6 would be the opposite. This length opposite the right angle will be the hypotenuse, meaning this one is the adjacent. Since we're finding the angle, we'll circle the lengths that are known, which are the opposite and the adjacent. The ratio and triangle that involves opposite and adjacent is tan. So using the triangle TOA, covering up the function of tan, since I'm finding the angle, will require inverse tan on our calculators, and then the opposite length, which is 6, divided by the adjacent length of 5. This gives me an angle of 50.1944, adding on the 180 degrees to finish with a total bearing of P from R of 230.1944. They've not given me a value to round here, so I will just round to the nearest degree, which would be 230 degrees. The last rule of bearings is that all bearings must be given as 3 figures. In this case, our answer was 3 figures, so we didn't need to worry about this. Let's say for example we finished with an answer of 90 degrees. We would need to represent this using 3 figures, so we would have to put a 0 as a placeholder in front of the 2 digits. This is a common way that marks are lost, so something to look out for. Here's a question that I completed earlier. It appears as though I've made some mistakes. Pause the video and let's see if you can spot what they are and write some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.